Section 5.5, completing the square. Whoa, I'm hearing an echo, that's weird. We are talking about solving quadratic equations, ax squared plus bx plus c. So far we've used the technique of factoring. Graphing we're going to come back to later. And today we're going to use completing the square to solve quadratics. So new technique. Take a look at these. These are all factorable. Okay? But if you look at the left side and the two equations there compared to the right side, what is different? This is like Sesame Street. What's special about the ones on the left that's different from the ones on the right? Dylan, your shirt makes me want to ask you because it looks so Sesame Street-ish. What do you think?
I actually raised my hand because I thought those were all evens, but they're not. So.
What do you think?
The ones on the left, the roots are like the same digits.
Okay.
Just with a plus or minus.
Okay. So let's take a look. If we factor this, what multiplies to 9 and adds to 6? 3. So you get x plus 3 times x plus 3. Or you get a perfect square. A perfect square factor. Does that make sense? X plus 3 times x plus 3. What about the one on the left, lower left? What's that one going to be? X minus 10 times x minus 10. What about on the right? What multiplies to 15 and adds to... quick before I reveal it. 5 and 3. Okay, and the one below? 7 and 1. So how are they different on the right from the left? The ones on the left are perfect squares. The ones on the right, they do factor, but they don't factor as perfect squares. We're going to be looking at trying to factor equations as perfect squares. So the ones that you see on the left are the ones we're shooting for. So, not all quadratic equations are factorable. So take a look at this one right here. You look at it and you go, let's factor. What multiplies to 2 and adds to 6? Nothing comes to mind right away, does it?
6 over 2.
Such problems, they have solutions, but they might not be rational. That means they might be square roots. So we got to figure out. We can still find them, but we can't find them just by factoring. We got to do another technique. So we're going to use completing the square. Now, if I were to say, if we got rid of the 2 and we turn it into something else, then could we factor it? And the question is, what will we change that 2 into to make it something that could factor as a perfect square? 9. Good. 36 would also? No, 36 wouldn't work. But you're on the right track. You did find a perfect square, okay? So if I change that to a 9, now suddenly I'd have x plus 3 times x plus 3. I'd have a perfect square. Can I just take a number and change it? I can, as long as I'm careful, right? There's another step involved. You can, all right? So that's the technique, and I'm going to teach you how to change it, to make it something that you like, okay, in a minute. But first we're going to do a little practice, okay? We want to create perfect square trinomials. So we're starting with two terms, the x squared and the x term. X squared plus 4x plus something is going to give us a perfect square factor. 4. Good. What about the next one?
1.
Well, what's the constant that you want to put in there? 1. And that would be because you'd say of x plus 1 quantity squared. If you FOIL that out, you're going to get that perfect square trinomial. You guys getting the idea now? Okay, so don't call it out. What do you think you would put in for the next one? I'm giving a couple people to think about it. What do you think the next one's going to be? What do you think, Libby?
9.
9.
And then it would be like x minus 3.
Good.
Squared.
Good. And it's going to be x minus 3 quantity squared. Okay? Now, the last one is the one that's going to really impress me if you get it. You think?
I think it's 9 over 2.
That's a really good guess. Not quite. Anybody else? Yeah?
9 over 4.
That's exactly right. Okay, you should share some with him because he got you halfway there.
Yeah, I really have no idea.
So that was a guess?
Yeah.
Give me, oh, wow. Okay. Let's look at the pattern here. Okay, and we'll see how Carter got really close.
I've read the textbook.
There you go.
I
That
have
helps.
a lot of free time.
Awesome. Okay, so let's look at the pattern here. See this thing right here? In order to get the term here, you didn't realize you were doing this, but you took this and you divided it by 2. And then you squared it. So what's 4 divided by 2? 2. 2 squared is 4. The reason you divide it by 2 is because you're going to get a, when you square it, you FOIL it, right? You're going to get x squared plus 2x plus 2x plus 4, right? So you're going to get 2x and a 2x, so you get 4x. So you're dividing the thing by 2. So you took this and you divided it by 2, right? Take this divided by 2 and then square it. You get 1. Take this, divide it by 2, right? And then you squared it, you got 9. Take this, divide it by 2. 3 halves. Square it, and you get 9 over 4. That's the pattern. Okay. So when we're dealing with perfect square trinomials, we put them in this form, ax squared plus bx plus c. A being the coefficient of the x squared term, b is the coefficient of the linear term of the x term, c is the constant. You get it in that form. Once you have it in that form, you know that you can figure out the constant that makes it a perfect square. The constant is just b over 2 squared. Okay, that's it. So now that you know the rule, b over 2 squared. 2 over 2 is 1. 1 squared is 1. Negative 6 over 2 is negative 3. Square it is plus 9. Negative 3 over 2 is 3 halves. Square it, 9 over 4. Okay, so once you know the pattern, you can solve it really quickly. That's the idea behind math, right? We're lazy, generally, mathematicians. We don't like to do the same thing again and again and again. So once we figure out a pattern, we figure out the rule, and then we use the rule instead of doing all the silly, tedious steps every single time. Figure out the rule, use the rule, solve it much more efficiently. All right, let's move on. So I'm going to teach you the completing the square process. I don't care so much that you write every single one of these steps down, is that you follow it and understand the idea. Okay? Remember when we took that one like this and we said this would be a lot better if it was a 9 instead of a 2. We crossed it out and put a 9 there. That's what we're going to do right now. So here's the process. First step is isolate the x's on one side. So you get your x squared plus your 6x and you put that on one side. And you move that 2 to the other side to look like that. X squared plus x with a negative 2. Now notice I left a little space. Get in the habit of doing that. Put a little space. I put a little line there so I know to put something in there in just a second. All right? Now, add b over 2 squared to both sides. We're completing the square. We're figuring out what goes in here that makes it a perfect square factor. We figured out before that it was a 9. So let's stick it in there. But this is the trick. Remember I said you can't just change number? You can, but then you have to, if you're going to add 9 to one side, you have to add it to the other. And that's the whole trick of completing the square. Changing that number to a number you can factor as a square, and then adding that number to the other side. So x squared plus 6x plus 9 equals negative 2 plus 9. Next step, factor it. You got a perfect square, so it's going to look like x plus 3 times x plus 3 equals 7. Keep going. I want to take the square root of both sides. And remember, when you take the square root of both sides, if you have an x squared equals something, you always have to do the plus or minus. Every single time when we're doing these problems, don't forget the plus or minus. So, square root of x plus 3 squared is the square root of 7, but I'm going to plus or minus, so I'd say x plus 3, by evaluating the square root of this side, square root of that side, x plus 3 is plus or minus the square root of 7. Last step, you want to get x all by itself. So you subtract 3 from both sides, and you'll get x equals negative 3 plus or minus square root of 7. And that is your solution. Now, what does that mean in terms of the parabola or the answer? Remember how we talked about how, let me get a little pen, how the solutions represent the places where a parabola would cross the axis? And now you got this result here. What does that mean? Somebody have a calculator real quick and figure out what is negative 3 plus the square root of 7. What is that in decimal form? You figure out, Paige, you figure out negative 3 minus the square root of 7. You're going to do negative 3 plus the square root of 7. You do negative 3 minus the square root of 7, okay?
It's negative 0.35. I got 2.6.
Negative 0.35.
Yeah, with the 27.
Okay, and you got,
I got 2.645.
that doesn't sound right because it should be more negative. Negative 3 minus the square root of 7.
Negative 5. Yeah.
Negative 5.6? Negative 3. Okay. So the idea, though, is that one place where it crosses the axis is going to be at 0.35, actually negative 0.35, and the other place where it crosses is going to be at negative 0.56. What I'm trying to show you is that these two values represent 2 points, 2 separate points, and that's where the parabola is crossing the axis. Okay? And you can figure out what those values are with your calculator, with your legal calculator. All right, so let's try this one together. Let's go through the steps that we just did to complete the square. Yep.
So then why did you leave that space open?
Because that's where I'm going to add the 9 in each time. We'll do it again right here. Okay? So, x squared minus 14x plus 19 equals 0. First step, isolate the x's. Get the x's on one side, put the constant on the other. Leave a little space for yourself to add a constant in there once you figure out what it needs to be. Okay, hopefully you found something like this. X squared minus 14x plus something equals negative 19. Now we want to figure out what that something is. What do we need to complete the square? What value are we going to put in there? Now this is a little strategy that I use. I write down what b is. b is negative 14. b over 2 is negative 7. b over 2 squared is 49. Which value do we put in that little blank spot? 49. It's the b over 2 squared, right? That's the perfect square portion. So I add 49 to the left side. Then what do I have to do to the right side? Add 49. I add 49 to one side. Add it to the other side. And now simplify and factor. What do you get on the left side? What do you get on the right side? Notice the term when I factor is b over 2. You see that? Here's b over 2 right here. There it is, and that's where it goes right in here. That's why I found it. That's why I know to stick in there. Okay? So now I have x minus 7 squared is 30. So what am I going to do next? Thor?
You're going to put a square root around both of them and put a plus or minus in front of them.
Excellent. Take the square root of both sides and remember to make it be plus or minus. Okay, good. It's plus or minus square root of 30. So x minus 7 is plus or minus square root of 30. Can I simplify 30 any more? Is it as simple as it gets, Libby?
Yeah.
That's as simple as it gets. Good. So what's the next thing I want to do then?
Add 7.
Good. Add 7 to both sides, and I'll get x equals 7 plus or minus square root of 30, and I'm done. Notice those represent 2 different points. 7 plus the square root of 30, and 7 minus the square root of 30. Those are the 2 places it's going to cross the axis. All right, next one. Even if b is odd, the process remains the same.